Hello, in this video you will learn how to use operator overloading in C#. In this case it's .NET 10, C# 14, the latest version. And another thing, you'll learn how to do it in a new way, that C# 14 way, the newest, latest way, which gives you a massive performance improvement, perhaps not 3 or 4 times, but 1.5. And we do have a little demo here with millions of records being added in that override, and kind of comparing it to the old way. It does, even if in these sort of very basic, very rudimentary benchmarks, there is an improvement. Essentially, what we are looking at, operator overload, when you have something like this, for example. Let's just look at a little example if you don't know about it. If you do know, it's not very interesting. Let's just say I1, so there's no confusion anywhere here. So you have something like this, but then you might have, say, I1 plus equals 5. Let's take the suggestion. So that is essentially the operators, right? You have I1 add 5 plus equals, so that will add 5 to I1. Now, obviously, we'll be looking at a more difficult arrangement. We'll have an object of sorts, and we'll have its own override of this plus equals through an object. It will have, and you can add all kinds of customization to that. But let's take a look first at the old way and then how it compares to the new way. So, the way you create your operator, at least in the old way, and it will be very similar in the new way, but essentially you can override any struct like that to have that operator. So it's not necessarily going to be applied to your integers or something like that. It's very useful, in fact, when you're building libraries, when you often have to add something not just to one value, but to a few values. So different currencies, perhaps different arrangements where you have to add values to those separate places. It might be user stats or something of that nature. You might need to do that. So in this case, in this example, we have a little struct. We have currency and we have the amount. Very simple arrangement, essentially. You might add that in a table where user has a wallet, and you have your list of currencies and amounts. But it will still at that point be a struct or maybe a class at that point, so you might override that and look into that arrangement as well. But this is a more basic one, but still. You will need to add that based on some arrangement, and perhaps you might even need to convert the currency from a base currency. So that's where these overrides come in. You don't want to just add the value when someone's depositing or withdrawing. You also maybe want to convert a certain currency from which it comes, or maybe you always have to convert to your base currency before you add it to the chosen currency like we have here. So the way you override the operator, and that's the main thing, you have your public static, whatever, we have money old way, and then you add your operator. So in normal integer, and you can override those as well, you might have plus equals, and this is how it will be used as well. You just have your struct name, public static, whatever it may be, plus money old way left, money right. So this money left will be your result, right? What you add to, and this is what you add. If we go back, say somewhere here, like this is your old, so this is your result, which will take this part, and it will also take this new part, and then it added together. Let's get back to this just quickly. You can see right here, we have right, and then we have left. So left is what you assign to, And again, you don't have to create a method or anything like that. You don't have to provide parameters like that. Your parameter, left one, is what you assign to. And then this one is whatever is on the right, whatever is created on the right. Essentially, it has to end up being that object, but you could have many other arrangements. It could come from a method and all those things. But more importantly, at this point, you could have a method here. The difference now, when we're looking at C# 13 and C# 14, as it says this sort of explicit comment here, we create a new object every time we assign it that way, because we essentially create a new object. It's quite visible. We have new and we assign it that way. And also, let's not forget, there's plus, and if there's plus, there's minus. So addition and subtraction, you can override both of those things. So when you start doing it, quite simple. You have your struct, or whatever you have, and you have operator. The keyword here is operator. Then before your parameters, you have minus or plus. And then you have left, which is the part before plus equals or minus equals. And then after that, you have your new construct, whatever you're adding. So that will be constructed when you're adding it. But the problem is with the old way, again, we are constructing it essentially for no reason, because it's the same sort of thing. We just need to add those values every time we add or subtract. So in C# 14, there's a new way, and let's take a look at that. We have this new way, again, sort of the same if we compare it to this, more or less, right? We can private set and get a bit different, but more or less the same. Now, the way we override, still more or less the same. We have plus, we have minus, and basically, again, the same thing. We just do those additions and subtractions and return new and all those things. The difference is here. We have this new method that sort of helps to override the whole thing completely without having to go too far. Just something to note before we go deeper into that. There's plus equals. There's also minus equals. So if you want to do the new C# 14 way assignments, you want to do them both. So you do public void operator, you override the operator right. So you just override how something gets essentially added from that new arrangement. And there's also decrements and increments. But you can do these overrides as well on the old way. It doesn't matter. Essentially, you have, looking at a sort of practical perspective, you override public void operator for all these cases, like here. Plus equals or plus plus, the plus would be +1. Although, as you can see here, we are actually overriding +1. And we are adding +1. So you can actually make, if you have that custom case, you can actually make ++, like you have in a for loops, in some of these arrangements, you can actually make it whatever you want. Maybe it +1000, or maybe it actually checks something else throughout your code. The async await is a bit more tricky in these cases, so something to watch out for. You probably don't want to overcrowd these arrangements, and perhaps those places are not the cases to get into this arrangement, but it is possible to actually do some operations here, some checks and balances on these values that you provide and that you get. But obviously this will probably be static, because in ++, in increment or decrement, like we have here, plus plus is increment, minus minus is decrement. We don't really have a way to provide any parameters, so it's probably just going to be a static value, but the static value can be whatever you want it to be. So it's something to consider as well. Perhaps might be quite useful in some certain cases. Probably very few cases, but it can be useful as well. But essentially, what we do in this new way, we just override all of these things. And then we have this more custom arrangement to specify the actual things what we're doing. Like here, we add the right amount, we add the minus amount from the right. So plus or minus, minus here, plus here. But the important thing is to add that, because in this case, we are not creating a new object anymore, we're just allocating. If it's matching, if this override right here for operator plus will be matching this override, then we don't recreate the object, or don't create another object rather. We just reassign the actual value to existing object, and we avoid messing with that new memory allocation. And we do have a little example here. Maybe we can run it, but we have somewhere here. Essentially, you have millions of records, so it ends up being fewer records. Obviously, it does decrease a bit with 100,000 records. It would be like 1.3 times faster with a new way, or 1.5 maybe, but with more records it will decrease a bit, but it's still a bit faster. And if you're dealing with not 1 million records perhaps, or 2 million records, now probably you won't be dealing with that many at once, but you might have some asynchronous arrangement where you have different threads and things. It is worth considering using that. It just adds a tiny amount of code to the whole thing, and it certainly doesn't change anything, as you have seen. Overriding is certainly quite straightforward and easy. It doesn't change anything in terms of you doing. You're just adding those basic additional arrangements, and that's it. And you're improving the performance, because we're not creating a new object for no reason, for absolutely no reason in this case. We're just reallocating some values into those existing objects. And that's what makes the performance better. But in general, this is how you use this thing. And again, it can be probably a pointless exercise at times in most coding scenarios, but in some cases where you are reusing it, especially in something like this, where you have the same amounts or the same currencies and amounts, and you just have to kind of go through them. Financial applications especially could use something like this almost all the time, whatever it may be. So do consider this, and if you want this code, it is available on Patreon. If you want to look at more C#14, C.NET 10 videos, take a look at this channel. There's great videos about .NET 10 minimal APIs and other arrangements such as Blazor and some crypto arrangements where something like this might come definitely in handy. And with that said, we will conclude this video.